Okay, so in this unit, we're going to focus on polynomial functions. In this particular lesson, we are going to look at identifying the transformations for polynomial functions. Specifically, like if we have a vertical stretch or a vertical compression, a reflection, translations, we're also going to introduce a new parameter that tells us if we have stretches, compressions, or reflections in the horizontal direction. So up to this point, we have looked at identifying vertical stretches, compressions, and reflections, the x-axis reflection. Now we're going to go horizontally as well. So this piece of prior knowledge is something that we've already learned, is how to identify each of these types of transformations. And so we identify our parameters. The 6/5 is our A parameter. And if it is positive, that means there is no x-axis reflection. So for the x-axis reflection, in this case, there is not one. For a stretch or compression, we look at the absolute value of A, remember, and the absolute value of a number is positive, and what we compare that to is 1. So 6/5 is an improper fraction. 6, the numerator, is larger than 5, the denominator, which means that this is greater than 1. And when our parameter is greater than 1, we have a vertical stretch. The parameter, or the factor rather, of that stretch is the value we compared to 1, the 6/5. So if we have a stretch, we cannot also have a vertical compression. You can have one or the other. Then translations. So remember, the number directly added or subtracted from the x, we have to take the opposite of that number to get what we call h. So our h would be the opposite of 1, which is -1. And h is our horizontal translations, left, right. So negative is in the left direction on our number line from the origin. So that means that our horizontal translation or shift is to the left. And the number of units would be 1 unit. Then we have the number that is outside of the parentheses, and that value is our k directly. So the only time we do the opposite is with h. K is a -4 here. K is about vertical translations, up, down. So this, we do have a vertical translation. I guess I should have. The direction, because this is a -4, means we're going down, which is the negative direction from the origin. And then the number of units would be 4 units. So we're taking all of this, still using all of this, and then we're also going to introduce a new parameter, like I said, that tells us we have horizontal stretches, compressions, and y-axis reflections, which is a type of horizontal reflection. So this is a resource to just make sure that we are remembering how to interpret our parameters correctly. So notice the position of A is in the front of the function rule. So it's the multiplying factor or coefficient of the function rule. And that A value, if it's positive, there's no reflection across the x-axis. But if it's negative, like it says here, A is less than 0 would be negative, then there is a reflection across the x-axis. Then we look at the absolute value of A and compare it to 1. If that absolute value is greater than 1, we have a vertical stretch. If it is less than 1, we have a vertical compression. Here's our new parameter. Our new parameter is identified as 1 over b. And this would be a good thing to be highlighting or circling or putting a star by in your notes. Notice its position inside the parentheses times the x minus h portion. That's where we find this parameter. We don't actually use that value though.
What we actually have to do is use its reciprocal. So this is the reciprocal of 1 over b, which is b. We look at if b is negative, we have a reflection now across the y-axis, which is a horizontal reflection, a left to right reflection. Then we also, just like with A, we look at the absolute value of B and compare it to 1. If that absolute value is greater than 1, we do still have a stretch, but now our stretch is horizontal, left or right, depending on whether or not we have a reflection across the y-axis. If that absolute value is less than 1, we do still have a compression, but now we have a horizontal compression. And the factor of our compression is the B value, the absolute value, just like it is for A. So going back to this, remember, if our absolute value of A is greater than 1, we have a stretch, but the type of stretch is vertical with A. If the absolute value of A is less than 1, we have a compression, but the type of compression is vertical with A. With our 1 over B turned into B, it's reciprocal. Greater than 1 still gives us a stretch, but now it's horizontal. And less than 1 still gives us a compression, but now it's horizontal. Negative still gives us a reflection, but now it's across the y-axis, a horizontal reflection. So here we're going to look at some examples, and we're going to build our understanding to getting to the point to where we can look at a complex function and identify all of the transformations. But right now, we are only going to focus on one parameter and determining whether that parameter is giving us a vertical stretch or a horizontal stretch. So with this first example, our parameter is the 3. Notice where it is in the front of f of x. So it's in front of the function rule. That makes it an A parameter. So we look at the absolute value of A, which is the absolute value of 3, which is 3, and compare it to 1. 3 is greater than 1. So that means we have a stretch. The type of stretch we now have to realize we have is a vertical stretch because we're working with A. So this is a vertical stretch. By a factor of 3. Make sure that you include this information of the factor. That's what it means by here, include the factor in the instructions. Looking at this second example here, f of this 1/2 of x, notice the position of the 1/2 inside the parentheses and times the x portion. That makes it, by definition, 1 over b. So 1 over b is 1/2. Don't use that number. With this one, we have an extra step where we have to do the reciprocal. So 1 over b becomes b over 1, which is b. And 1 over 2 becomes 2 over 1, which is 2. Then we look at the absolute value of b. And the absolute value of 2 is, of course, 2. And we compare that to 1. 2 is greater than 1, so we have a stretch. Here we have to realize the type of stretch we have is horizontal because we're working with b. So this is a horizontal stretch by a factor of 2. All right, so in these next examples, we're going to focus on being able to differentiate between a function that has a vertical compression or a horizontal compression. And so again, the position of the parameter is going to tell us whether it's an A or a 1 over B to start with. So in this first example here, we have a 1/2. The position of it in front, outside of the parentheses, makes it an A parameter by definition. And so then we look at the absolute value of our A, and the absolute value of 1/2 is still 1/2 because absolute values are positive. And then we compare it to 1. Now here we have to realize, because the numerator is smaller than the denominator, this fraction is less than 1. We call that a proper fraction. So because our parameter, the absolute value of our parameter is less than 1, we have a compression, always. Now we have to know the type of compression. And with an A, that is our vertical compression. So we end up here with a vertical compression. By a factor of 1/2. So just like with the previous ones, what we compared to 1 is our factor. With the second example here, we're looking at our parameter being 8. Notice its position inside the parentheses. Here's where you got to be careful. And this is where the practice of working on your assignments helps make sure that this happens, because you have to realize, because it's inside, we're not going to use 8. That by definition is 1 over B. We're not going to use 1 over B. We want to use B, which is its reciprocal. So if 1 over B is 8, 8 is the same thing as 8 over 1. And so when we do its reciprocal, it becomes 1 over 8. So this is that. And then we do the reciprocal. And here is what we then use. So now we look at the absolute value of B, which is the absolute value of 1/8, which is 1/8. And that's what we compare to 1. And again, this is a proper fraction because the numerator is smaller. That makes this number smaller than 1. That's our number sense. And so again, we have a compression because our absolute value is smaller than 1. The type of compression we have to realize now, because we're working with 1 over B/B, is horizontal. So this gives us a horizontal compression. By a factor of the 1/8. All right, so now we're going to add to this our understanding of reflections. We have 2 types we have to know to identify in which type we've got. Our reflection across the x-axis, which is a vertical reflection, so it goes with our A parameter, and a reflection across the y-axis, which is a horizontal reflection and goes with our 1 over B/B parameter. In this next set of examples, we're looking at still figuring out if we have a stretch or compression, but adding to that whether or not we have a reflection across the y-axis or the x-axis. When it says here, include the factor, please remember the factor corresponds to the stretch or compression. Reflections do not have factors. Reflections do not have factors. All right, so in this first example here, we have this parameter of -2. By its position outside the parentheses, we know that it is an A parameter. So the first thing I'm going to do now is recognize that it is negative, meaning that it's less than 0. And because it's negative, I do have a reflection. The type of reflection, because my parameter is an A, has to be my x-axis, which is my vertical type of reflection. So this gives me an x-axis reflection. I'm just going to put a box around it because I'm going to do some more work. for the next part, because the next part is now to figure out stretch, compression, what type, what factor, that kind of a thing. So remember, when you're doing a stretch or compression portion of the problem, you always do the absolute value of your parameter. An absolute value is always positive, and you always at this point compare to 1. So 2 is greater than 1. Anytime your absolute value is greater than 1, you have a stretch. The type of stretch depends on the parameter. So because we have A, we know that this is a vertical stretch. And our factor for our stretch is the 2. All right, let's take a look at the second example. So in this second example, we have this factor or this multiplier here of -3, which is inside the parentheses. That makes it, by definition, a 1 over b. So remember, this being an integer starts off with a denominator of 1. With our 1 over b, we want to do the reciprocal of that, which is b. And so -3 over 1 becomes 1 over -3, or -1/3. Because it's negative, meaning it's less than 0, there is a reflection. The type of reflection we have here is our y-axis reflection, because that's a type of horizontal reflection, left to right or right to left. So this gives us a y-axis reflection. For the next part, where we look at the stretch compression, remember we have to use B. We want the absolute value of B, which is the absolute value of the -1/3. Again, absolute value of a number is always positive. So this is equal to +1/3. And for the stretch compression, you compare to 1. And 1/3 is less than 1, being a proper fraction, numerator smaller than denominator. That means we have a compression. Anytime our factor is less than 1, we have a compression. The type of compression we have depends on the parameter. And so since we're working with B, we have a horizontal compression. And by a factor of that 1/3. So in the next set of examples here, we are putting everything together. So we're still looking at identifying reflections, stretches, compressions, and now we're adding our knowledge of translations. And translations we've worked a lot with previously. So we're just refreshing our memory here and adding that to our problems. So we have to describe all the transformations for the graph of the function. That's all of them. We need them all. And I recommend that you still start with your A or 1 over B parameter, do reflections, do stretches, compressions first, then move on to H and K. All right. So in this first one, what we have to recognize is that negative sign in front of that X is -1 times X. And so that actually is our parameter. By its position inside the parentheses, that makes it 1 over B. And so 1 over B is equal to -1, which also, like other integers, has a denominator of 1. So we do its reciprocal, which is B. And what's interesting about -1 is that it is its own reciprocal, meaning that the reciprocal of -1 is still -1. It's one of only 2 numbers that's true for. The other number that's true for is 1. So the reciprocal of 1 is 1, and the reciprocal of -1 is -1. And so because it's negative, we do have a reflection. That reflection would be a y-axis reflection because we're dealing with B. So then we move on to the stretch compression part, in which we look at the absolute value of B. So we're looking at the absolute value of our -1, which absolute value is always positive, so this would be +1. Now here is a special situation that we have to understand how to interpret, because remember, we are comparing to 1 for stretches and compressions. So we're looking at, is our absolute value greater than 1 or is it less than 1? Well, here we have a special situation because 1 is equal to 1. So what we have to remember that means is that there is no stretch, no compression. Now that's not really part of our answer unless we're specifically asked to say yes or no to a stretch or compression, because if there's no stretch or compression, it's not a transformation, it's not changing anything. So now I move on to my next parameter. And here's where, again, H and K position's important. So in this case, our next parameter is -5. Notice that it's after the parentheses. When it is after the parentheses, that is always by definition your K parameter. And so our K is -5. K does translations up or down, depending on the sign. If K is positive, then we go up, which is the positive direction from the origin. When K is negative, the function moves down in the negative direction from the origin. So because our K is negative, this means that we have a translation down, and we always do the units, and units are always positive. This is a mistake I sometimes see people make. Units, like factors, are always positive. So it's 5 units, not -5. All right, for the second example here, the first parameter we have is the -3. By its position in front of the parentheses, that tells us it must be A. So we do not do the reciprocal for this one. So our A is -3. Because it's negative, we do have a reflection. We have to know the type of reflection with A is our x-axis reflection. And you have that in your notes. If you're not sure, keep checking so that eventually it will stick in your head. So then we move on to the stretch compression here. So again, no reciprocal. We use that exact value of A, take its absolute value. Absolute value of a number is always positive. So this is equal to +3. For the stretch compression, we compare to 1. 3 is greater than 1. Anytime our factor is greater than 1, we have a stretch. We also have to know the type of stretch that goes with A, which is our vertical stretch. So we have a vertical stretch by a factor of 3. All right, so now the next part, and that comes from the next parameter. Here again, you want to be careful because notice here that our -9 is now inside the parentheses. Here we have to remember we have to take the opposite of that minus or -9 to get our H. So the opposite of negative or -9 is +9. So we now know that our H is +9. H is about horizontal translations. And think the word horizontal starts with H. So that goes with, and that's just for translations. But H is for horizontal translations, left or right. And so if H is positive, we move to the right because that's the positive direction from the origin. When H is negative, we move to the left because that's the negative direction from the origin. So because we have a positive 9, that means that we have a translation to the right 9 units. Finish that up. All right, so that puts everything together. Our new stuff with our horizontal stretches and compressions and our y-axis reflections compared to our old stuff, vertical stretches, compressions, and x-axis reflections. And now we've added K and H and talked about those. The position of the number tells us whether it's H or K. We've got to remember with H to take the opposite so that we know that we're going the correct direction for horizontal, left versus right. And that pretty much sums it all up for this one.